OK, so now that we've derived a relationship between acceleration, velocity, and time, now we want to move on to figure out what happens to position when everything is changing. So in order to help us do that, I've drawn here a velocity versus time graph. OK, so the slope of this will give us the acceleration, as we saw before. But I want to go backwards now. I want to see how we can find out what the position or the change in position is from this graph. So let's look at a little time interval, delta t, here on the axis. So the vertical value of this is some velocity. And so we know that if I write velocity, that is equal to the change in position over the change in time. And so we know that velocity times delta t is going to give me the change in position. But velocity times delta t is just the area of this box. So the area of this small box here tells me how much my position changes during this small time interval delta t. OK, so now if I want to figure out what happens over a longer time, to get rid of that first, now let's say that I start over here at some time t initial. I start at some initial velocity here. And then I'm going to some time t final. And I want to figure out how far I go between t initial and t final. So in order to do that, I have to add up the areas of all of the boxes that are underneath the velocity versus time curve. OK, so in order to do that, let's draw it in a more geometrically friendly way. So let me make this a continuous shape. Let's redraw the axes over here and fill that shape in as just a continuous area. So now if I go over here, the area of this big green box here is going to be the displacement. It's going to be x final minus x initial for this motion between these two times. And so we can then take this and use geometry to calculate this area.